Imagine standing on solid ground and realizing that beneath your feet lies a world deeper than any ocean, darker than outer space, and more unreachable than the moon. Humans have explored space, walked on the moon, and sent robots beyond our solar system, yet when it comes to drilling into our own planet, we've barely scratched the surface. So the question is simple, but the answer is astonishing. What's the deepest hole we can possibly dig? To understand this, let's start with the scale of the Earth itself. The planet's radius is about 6,371 kilometers. If Earth were the size of an apple, the deepest hole humans have ever drilled wouldn't even pierce the skin. It would be more like a tiny pinprick. Despite all our technology, drills, and engineering, we are still essentially surface dwellers. The deepest hole ever dug by humans is known as the Kola Superdeep Borehole in Russia. Drilling began in 1970 during the Cold War, not for oil or gas, but purely for scientific curiosity. Scientists wanted to understand Earth's crust, its composition, temperature, and structure. After nearly 20 years of drilling, they reached a depth of about 12.26 kilometers, or roughly 7.6 miles. That's deeper than Mount Everest is tall, and yet it only reached about one-third of the way through Earth's continental crust. At first, this sounds impressive, and it is. But what they discovered down there showed why going deeper is incredibly difficult. One major problem was heat. Scientists expected temperatures around 100 degrees Celsius at that depth. Instead, they encountered temperatures closer to 180 degrees Celsius. At such extreme heat, rock doesn't behave like a solid anymore. It starts acting more like plastic. Drill bits warped, machinery failed, and progress slowed to a crawl. Pressure was another nightmare. As you go deeper, the weight of the rock above increases dramatically. At extreme depths, the pressure is so intense that it can crush equipment and close drilled holes almost as fast as they're made. Imagine trying to drill into something that constantly squeezes itself shut behind your drill. That's what deep drilling is like. But heat and pressure aren't the only obstacles. There's also the unexpected behavior of Earth itself. At great depths, scientists discovered water trapped inside rocks that were supposed to be dry. This water didn't come from the surface. It was chemically bound within minerals and released under extreme pressure. When it escaped, it caused instability, fractures, and even damaged drilling equipment. Earth, it turns out, is far less predictable the deeper you go. Now, you might wonder, why can't we just build better drills, bigger machines, stronger materials? The answer lies in physics and engineering limits. Drill bits wear out incredibly fast at extreme depths. Replacing them requires pulling kilometers of drill pipe back to the surface, a process that can take weeks. Every additional kilometer increases cost, time, and risk exponentially. At some point, the energy required to drill deeper becomes greater than what's practical or economically possible. Even oil and gas drilling, which is heavily funded and commercially motivated, rarely goes beyond 10 to 12 kilometers. The deepest oil wells in the world are around this range, and they push technology to its absolute limits. These wells are often drilled horizontally after reaching depth, because going straight down any further becomes inefficient and dangerous. Now let's imagine a hypothetical scenario. Suppose money was no object, and we had unlimited time and resources. How deep could we possibly dig? The theoretical limit is not the center of the Earth, and it's not even close. Long before reaching the mantle, which starts roughly 30 to 70 kilometers below continents, we would face temperatures exceeding 500 degrees Celsius. At these temperatures, conventional drilling becomes impossible. Metal weakens, electronics fail, and even the strongest materials we know begin to break down. Some scientists have proposed exotic solutions. For example, instead of drilling mechanically, what if we used heat? Concepts like thermal drilling, where extreme heat melts rock, have been explored. There are even ideas involving lasers or plasma drills that could theoretically vaporize rock. While fascinating, these methods require enormous amounts of energy and introduce new problems, like controlling molten rock and preventing the hole from collapsing. Another idea involves using nuclear explosions to blast deeper into the Earth. This was actually considered during the Cold War. The idea was to use controlled nuclear detonations to fracture rock and create deep cavities. Unsurprisingly, the environmental, political, and safety risks made this approach unacceptable. Even if it worked, the result would be a radioactive, unstable mess rather than a usable scientific borehole. So realistically, the deepest hole we can dig with current or near-future technology is probably around 15 to 20 kilometers. Beyond that, we enter a zone where heat, pressure, and material limits all collide. The Earth essentially tells us, you're not welcome here. What's fascinating is that going deeper doesn't just get harder, it gets exponentially harder. Each extra kilometer down is more challenging than all the kilometers above it combined. That's why progress slows dramatically the deeper we go. Drilling the first kilometer might take days. The last kilometer might take years. Now here's where things get even more mind-blowing. Despite barely drilling into the Earth, we know a surprising amount about its interior. How? Earthquakes. Seismic waves generated by earthquakes travel through the planet, bouncing, bending, and changing speed depending on the materials they pass through. By studying these waves, scientists can map Earth's inner layers without ever physically reaching them. Thanks to this, we know that beneath the crust lies the mantle, extending down nearly 2,900 kilometers. Below that is the outer core, made of molten iron and nickel, and beneath that, a solid inner core as hot as the surface of the sun. We know all this without ever digging more than a few kilometers down. In a way, Earth has revealed its secrets through vibrations rather than holes. So why does digging deep matter at all? Deep drilling has given us invaluable insights into Earth's history, plate tectonics, and even the origins of life. Some scientists believe that life may exist deep beneath the surface, surviving in extreme heat and pressure, feeding on chemical energy rather than sunlight. These deep biosphere organisms challenge our understanding of where life can exist and even influence how we search for life on other planets. There's also a humbling psychological aspect to all this. Humans often think of themselves as masters of their environment. We build skyscrapers, tunnel under oceans, and explore space. Yet the Earth beneath us remains largely inaccessible. The deepest hole we've ever dug doesn't even come close to reaching the mantle. It's a reminder that our planet is vast, powerful, and still full of mysteries. If you were to drop Mount Everest into the deepest hole ever dug, its peak wouldn't even reach the surface. And yet, that hole is nothing compared to the Earth's total depth. This contrast highlights just how thin the crust we live on really is, more like the skin of an apple than a solid shell. In the future, technology may improve. New materials, smarter drilling techniques, and better heat management could allow us to go a bit deeper. But unless there's a revolutionary breakthrough in physics or engineering, we're unlikely to ever drill anywhere near Earth's core. The planet's internal heat and pressure form a natural barrier that no drill can easily overcome. In the end, the deepest hole we can possibly dig is not defined by curiosity or ambition, but by the laws of nature. Gravity, temperature, pressure, and material limits all work together to set a boundary. And for now, that boundary sits just a few kilometers beneath our feet. So the next time you walk on the ground, remember this. Beneath you lies thousands of kilometers of rock, metal, and fire that humans will probably never touch. We may explore distant galaxies, but the deepest parts of our own planet will remain forever out of reach. And perhaps that's what makes Earth so fascinating. Its greatest mysteries aren't above us in the sky, but right below our feet.